Hey, this is Ken. How's everything going? Today is Saturday. We are having a thunderstorm outside. What's your weather in your place? Today's kata is our first 4Q question, which is called Snail. In this question, we are giving an n times n array. We are asked to return the array elements arranged from outermost elements to the middle element traveling clockwise. Let's go through the examples. So this is the array in the first example, and this is the return we should have. From here we can see it's from 1, 2, 3, and then go down 6 and 9, and then turn left, which is 8, 7, and 4 and 5. And this is the last element. It's similar in the second example. I think these two images are more clear than the examples. For a 3 times 3 array, we need to go from 1 and go right and down, left and up and right again. So the 4 and 4 array, then it's a little bit similar. Go from the right to left of the first row and then go down, left, up, right, down, and left until the last element. Cool, I think this is quite straightforward and interesting. Let's head to the practice. Alright, I think intuitively what we can do is to generate a list of positions of the element. For example, we can generate from 0, 0, which is 1 in this 3 times 3 array, and then 0.1, which is the second element, and 0.2, and 1, 2, and 2, 2, and then go left, and go up, and go up, and go right. So to the last element at 5, which is the same in the second one. Well, I think it will work in this way, but I don't think this method is interesting enough. So what I'm trying to do is to have an easier way or more interesting way, I would like to say. I think if we think about this question in another way, we can think it like this. So we go through from left to right of the first row. After we reach the last element of the first row, we rotate this array counterclockwise and then go through the row. So here we go through the first row and remove it. Then we rotate it counterclockwise. So the 477 will be the first row after we rotate it, and 699 is the second row. 588 is the third one, and 477 is the fourth one. And then we repeat what we did in the 4 times 4 array. We take this first row, and then we just rotate it again, which will make 987 as the first row after 2 rotates. So I think you got my idea. The process will be take the first row and remove it, and then rotate it, and then rotate it, and then the first row, and rotate it and the first row until we take out all the elements. Right, let's actually write the code. So I think the first step will be quite easy because we just need to take the first row out of the array, which can be simply like this. So this is actually the first row. In this example, there will be this line would equal to 1, 2, 3, which is in a list, and this example will be 1, 2, 3, 1 in a list. Cool. And then we need to rotate it. Let's say rotate array. Oh, I missed a letter. So how could we rotate it? If you know a little bit about the function called zip, which is basically combine lists together and produce new lists. So we can do it like this. Right, so what will this return? So if we have this array here, then this line of code will return 187, 296, 3, 4, 5. Right, so let's change this format a little bit as I for I in array. This will return the exact same result. If we take this as an example again, then it will return 187, 296, 3, 4, 5, right? But this is a little bit different from what we actually want, because what we want have is to have an array like 3, 4, 5, 2, 9, 6, and 1, 8, 7. So how can we do it? I think that's quite simple if we do it like this. So after we take each row out of this array, we put it in a reversed order. So after we take this one out, we reverse it as 3, 2, 1, and the second row will be 4, 9, 8, and the third one will be 5, 6, 7. If we use zip to put them together, then will be 3, 4, 5, 2, 9, 6, and 1, 8, 7, which is exactly what we want. But please remember, zip returns iterator in default. We need to use the function list to convert it into a list. Right, then we have this function to rotate the array as we need it. So I think we can say rotate array. Since we need to take out the first row, then we can do it like this. Snail map. We take the rest rows out and use this part to get a new result. Right. But this line only applies when the snail map is not empty. So we can say if snail map we return this. In other conditions, we just return empty. Let's give it a test. Whoa, a big mistake here. So can only connect tuple, not list to tuple. Oh, right. So this here is a reason. So after we use this part, each row will be in a tuple instead of a list. So for example, after we rotate this array, then the first row will be 3, 6, 9 as we expected, but the type will be in a tuple instead of a list. So here, since the original one is a tuple, we need to change it to tuple. Simple. As well as this part. Here we have a tuple, here is also a tuple, and here is also one. The types are the same. Let's give it a try. Alright, as you can see here, even though we failed in both tests, but you can see the numbers are in the right order. The only thing different is the type of the result. I think this will be quite straightforward. Let's just turn it into a list. But instead of doing things like this, the correct way of doing so, let's remove those tuples we just added. So we make this part as a list. This part is also a list. The only thing we need to change is actually this part. As I just mentioned before, this zip returns tuples. So if we change it a little bit and do it like this, so we actually iterate through the result and make each element as a list, and then we can get a list from here. Let's give it a try. Cool, we passed the tests. Let's give it some random ones. Alright, perfect. Let's submit it and head to the next kata.